Last week, we talked just a bit about the mathematical practices. And if you're thinking, I could care less, that's okay. But if you're an educator or if you are a site or school leader and you're trying to figure out why students are not mastering the standards in mathematics, there may be a missing piece. We have the content standards, but we also have the standards for mathematical practices. We talked about the umbrella model. Well, I at least introduced it to you last week. This time, I'm going to go into another avenue of the thinking. So let me reintroduce you to the umbrella model using the mathematical practices. And then by the time we're finished, we're going to have some sample mathematics problems. And if you're thinking, I can't even start looking at math, we can use ChatGPT to support us in this process. In 2010, the National Council of Teachers of Mathematics decided that we needed to have a way to think about how we are understanding and processing and problem solving through the mathematics. These are the standards for mathematical practices. And what does the standards or what do the standards for mathematical practices mean to you? And you can take some time and read through this, but the SMPs focus on what it meant for students to be mathematically proficient. In other words, what can they do to think about their thinking when using mathematics or dealing with an equation, an expression, thinking about what does this table mean? So let me show you a way that you can look at the mathematical practices and what we can do in order to help students problem solve through the math. Depending on what state you're in, you can see the mathematical practices many ways. This is one way that the state of California will look at the mathematical practices. And as you can see, this sideways version, the overarching habits of mind of a productive mathematical thinker. And then you have all eight. There is another way to look at it, but I want you to see that these two are the overarching habits of mind, meaning make sense of the problems and persevere in solving them. You first have to make sense of it, and students have to feel like they can actually persevere and solve them. Then attending to precision. Now, I would argue that you always want to attend to precision. So if you're using a line graph, if you have an equation or you're solving a multiplication problem, you need to line things up. It needs to be linear or horizontal. You don't want to be the educator that is writing from left to right and then all over the place around it. Like you want to be, yes, left to right, top to bottom, but you don't want to put the problem on the left and then the answer down somewhere on the right, and it doesn't seem to line up because students see that and their minds become very chaotic. So we have to attend to precision, be precise. And then we go through the reasoning and explaining, modeling and using tools, and scene structure and generalizing. But I would argue that we could look at this slightly differently. The state of California also lists them like this next to the content standards, 1 through 8. And you feel like as an educator, you're like, 1 through 8, do I do them all? Do I do some of them? When is it appropriate to use them? And sometimes we just don't know. So let me show you what the National Council of Teachers of Mathematics and in the book Routines for Reasoning has come up with. Looking at the mathematical practices and the content standards in an umbrella model. So, with the Silicon Valley Mathematics Initiative and the book Routines for Reasoning, there is this overarching sense that students should always use what I would call a lead actor, MP1, make sense of the problems and persevere in solving them, no matter what. They need to be able to do this first. They have to have the confidence. They feel like they can grapple with the problem, that productive struggle. And then you have what is called avenues of thinking. So let me show you this first. You have mathematical practice 2, mathematical practice 7, and mathematical practice 8. These are considered the avenues of thinking, quantities and relationships, structure and repetition. So students typically will choose one of these pathways no matter what they're working on, whatever they're more comfortable with. However, maybe reasoning abstractly and quantitatively might make more sense when working on a mathematics problem, expression. Maybe looking for make use of structure. Maybe they need to just identify the equation. They don't have to solve for anything, but does this equation work for what the task is being asked? And then mathematical practice 8, look for and express regularity and repeated reasoning. Like when a student does repeated addition, that might be repeated reasoning. Well, 2 plus 2 plus 2 plus 2 could also be 4 groups of 2. So what's the reasoning and repetition behind that? So these are areas that I like teachers to really look at the structure. And we're going to focus on, last week we did MP2, reasoning abstractly and quantitatively. We are going to look for and make use of structure in this video. And then we're also going to use ChatGPT with a smarter balance sample item and how to look for and make use of structure. I do want to show you the rest though. Whenever students pick an avenue, sooner or later, you will want them to either construct a viable argument and critique the reasoning of others. You will want maybe for them to model with the mathematics. Maybe they are creating the equation. Maybe they're using a graph. So modeling with the mathematics, maybe they're showing you how they're counting. Maybe they are giving you a diagram on absolute value, meaning a negative, no matter what happens, whether it's negative or positive, above sea level, below sea level, you're still going to have a difference from zero. And it's always a positive number because 2,000 feet below sea level, even though we know it's a negative, it's still the difference is 2,000. If you have a bank account and you are negative $10, you still owe the $10 back. It doesn't just go away. So it's still a positive number. It's the difference from zero or the distance from zero, that interval. And then use of appropriate tools. Maybe you're using manipulatives. Maybe you need to use a meter stick. Maybe this is you're looking at metrics from for liquids. Maybe you're looking at liters, things like that. Use appropriate tools strategically, and then attend to precision. I would argue that you should always attend to precision. You may not do all 4 of these, but you will need to teach all 8 mathematical practices. So again, we're going to look for and make use of structure, and we're going to use ChatGPT and a couple of sample problems so I can show you how you can define what does it really mean to look for and make use of structure. So if you're a teacher in elementary and this isn't your area of strength, and even if it is, maybe you haven't been using the mathematical practices and you're trying to integrate that where it's not some type of separate entity that you're teaching in isolation. So let's go over to ChatGPT, grab a couple of sample problems and have a little fun. And if you feel like, I need to slow down and get in front of a computer, yes, pause this video, take some notes, open up 2 screens if you can, and try this in OpenAI. I do want to remind you, on December 7th at 7:30 a.m. Pacific time and 9:30 a.m. Central time, I will be hosting a webinar, 45-minute webinar on how to use ChatGPT in education and how you can use it to support you first before students really get this in their classroom, and a 15-minute Q&A. I want this to be fun and integrative so that you can try this while you're listening to the webinar. You can register by using this link or this QR code, or you can go into the description and grab it later. Let's jump over to ChatGPT. In front of you is OpenAI's platform. Yes, you can use any platform that you want. I just tend to live in OpenAI's ChatGPT because it's pretty consistent for me. What I want you to see is that I created the prompt already, and I have added 3 attachments. I gave it the umbrella model. I gave it, and this is my rendition of it. It looks slightly different in the book Routines for Reasoning. I gave it the standards for mathematical practice. Sorry, not, I gave it the content standards and the sample item that I wanted to work on. This is where I got the sample item. I got the sample item from the Smarter Balance Assessment sample item platform. And I chose grade 6, mathematics, and concepts and procedures. Why? Because concepts and procedures, first of all, that's where this content standard lives. If I were to deselect it, all of the standards live here, but problem solving, communicating and reasoning, and modeling and data analysis are all of the mathematical practices. When a student gets an item on the Smarter Balance Assessment at the end of the school year, and they have to work through and think, they may get mathematics where they have to compute, and then they may get 1 of these or 2 or 3 of these in the performance tasks or even in the computer adaptive test. So I wanted you to know that this is an area that the state of California struggles in, and communicating and reasoning is an area that we can boost pretty quickly because majority of the students live in near standard, and very small amount are in above standard, and very small amount are in below standard. So that means we have this chunk of students that we can push them all forward, and we want to, but that is an area of communicating and reasoning that we struggle with. And even in the language or English language arts and literacy, we struggle in speaking and listening. So those two tie together. So I wonder if we really focused on those two things and got really good at that, and then each year get really good at other areas, wonder how students would perform academically aside from the state test. So what I want you to see is that I chose the state standard. And so I chose an absolute value one. If you wanted to select any of the ones here, and it's not that one, so let me see if I can find it exactly. If you wanted to select, here it is. Okay, so if you wanted to select one of the, what I call the baseball cards, this is what they look like. So this is the actual sample item that I chose. I just took a screenshot of it and attached it to this prompt. And if you read this, it states, I want to use the umbrella model. I want to focus on always using MP1 because we need to persevere through the problem. And and at this time, we're going to use the avenue of thinking MP7. And I probably should say avenue of thinking, even though it avenue of thinking MP7. Look for make sense of structure. I have attached the sample SBA item for grade 6, absolute value, the umbrella model, and the content standard. Please, let's chat. Don't just spit out all the suggestions. Let's start with you and I should say having, it would know, having a discussion about what is making sense of structure, I should say, first. So I'm just going to hit enter and let it process through that. ChatGPT looks at the image and it reads everything that I gave it. And now it's saying, great. Let's start by discussing concepts making sense of structure. When we talk about making sense of structure, we're essentially encouraging students to recognize patterns or frameworks that can simplify a problem or reveal relationships between elements within it. This practice involves identifying regularities, repeated reasoning, or underlining properties that can guide problem solving. It's about understanding the architecture of a mathematical problem and using that insight to approach it more effectively. If you don't understand the mathematical practices, ask ChatGPT to help you. You can even have ChatGPT put it at a first grade level, a second grade level, so that you know how you're explaining it to your students, especially in grade 6, because a lot of people don't even realize that absolute value starts in grade 6. In the context of absolute value with a sample smarter balance assessment item, MP7 would involve guiding students to recognize the distance concepts associated with absolute values and how it fits within the structure of the number line. For instance, students could use the idea that absolute value represents distance from zero. We're talking about distances, and regardless of direction. So whenever we're talking about absolute value, we're talking directional. Like this is zero. And if you go 10 places to the right or 10 places to the left, even though the left might be negative, it's still 10 places or spaces or points, centimeters, whatever unit you're using. For instance, students could use the idea that absolute value represents distance from zero, regardless of direction, as a foundational structure to help them understand and compare values. What are your thoughts on focusing students on distance interpretations as a structural approach? Or is that's perfect? First question. I like the first question. And we could do the other question, or is there another aspect of structure you think would be valuable to emphasize? It's keeping me part of the conversation, but that is exactly what I would want to do first. Now, remember, I asked ChatGPT to have a discussion with me. Don't just blurt it all out, spit it out, and it just gives you like this waterfall of information. Way too much. So I got ChatGPT to slow down. And I'm glad this resonates with you. It's being nice to me. Um, Focusing on distance as a structural element allows students to see absolute value not just as a symbol or operation. A lot of teachers will just teach, well, if it's in the brackets like this, outside of the brackets, it's always going to be positive. That's confusing. Like, Kids, when they know why, it sticks in their brain longer, forever, hopefully. This perspective can help students make connections to real world contexts, like interpreting temperature, dif differences, or financial balances, where distance from zero is a meaningful concept. Sea level. I love talking about sea level, above sea level, below sea level. How would you like to approach this with the sample item? We could explore ways to introduce the structure of absolute value. Let's first introduce the structure of absolute value. Maybe start with sea level, then temperature, etc. Okay, so now it's giving me some step-by-steps of what this could look like. Begin by asking students to imagine a number line. I would push this a little bit more and say, for step one, what visuals could I use or make to really allow students to see this? Maybe we could make an example of this or use an iceberg, mountains, etc. Let's only look at step one. Like because it did give me like three things. We do want to do the number line sooner or later. Um, so I like this iceberg model, show an iceberg with a part of it above sea level and part below, mark level as sea level. I almost feel like you could create this. Like you could create using a tub of some of water and then maybe a fake iceberg where somehow it's submerged. I don't know what that would be yet, but that's certainly something that I would do as a teacher. Maybe it's a little bit, it's buoyant, it's above sea level just slightly, but it still is below. You could use a boat. I mean, there's certainly anytime it goes below water, it's still below sea level. Well, we're talking about the sea. We're not talking about a lake in the mountains. Let's be clear. But we could talk about that, meaning land and negative below the water line, the surface. Then mountain and ocean depth. There are a lot of visuals on that. You could have kids draw what that means, come up with a metric system. We use the metric system and come up with what metric they want to use. Example visual using an iceberg model. So many things. I also would challenge you in using temperature, whether it's degrees Fahrenheit or Celsius. You could talk about both of those units and values because negative 10 degrees and negative 10 degrees Celsius is different than negative 10 degrees Fahrenheit. You could talk about that because 0 degrees Celsius and 32 degrees Fahrenheit are the same places in value, meaning they're both the freezing point. So that would be a very interesting conversation. That is something, looking for and making sense of structure. And the idea is we want to get them to the point where they can answer what this means. Now I'm going to say, assuming that I taught this, how do I get them to being able to answer the sample item? Because you may not want to just give them the sample item. You want to use the sample item as a guide to say, I need to get them here. Because whatever curriculum product that your district uses probably has this, and you can use that as this is what it's saying in the product based on this standard, even though it might give you an array of mathematical practices. I still would argue that the National Council of Teachers of Mathematics and that umbrella model and using those avenues of thinking really would support you well, because we want kids thinking. You could use any of them, but there's something in the value of looking at the avenues of thinking first, and then navigating through the problem R3, 4, 5, and 6. So now let's enter that. Oh, that should have been a question, but it knows. So reinforce absolute value as a distance. So now you can showcase it on the number line. You can even use these same numbers. Guiding question, if absolute value is the distance from 0, what is the absolute value of negative 26? I would even argue for step 1 in this section, Where are the absolute value? Where are the absolute value lines? Like, I would want to see that, because attending to precision means we need to use the mathematical diagrams, mathematical content, mathematical language, and visuals. So it shows you, let's see if it's showing, here we go. It at least showed me what this looks like. So it doesn't, it's the distance, the direction from zero. And visuals in this situation will help students go, oh my, what I could do with this. And then at this point, I would say, what are the answers to the sample item? Now, just so you know that this sample item will give me the answers. So if I go back and select view answer key, it will tell you on a number line. So 26 and negative 26 is false, because are the same point is false. The distance between negative 18, 0 on a number line is negative 18 units. True. Let me look at this. I do want to look at it for a second. So the distance between negative 18 and 0 on a number line is negative 18 units. So it's basically asking if it's written correctly. Absolutely, it's written correctly. On this one, it's on a number line, 26 and negative 26 are the same point. No, they aren't. They might be the same direction. I mean, they might be the same value, but in a different direction. So that's why I wanted you to see that. And then the distance from negative 8 to 0 is the same as the distance from 8 to 0 on the number line. The distance is the same. So let's go and see if that's correct. Let's view the answers. So it's true. So the distance is correct. Remember, it's the same. It's a different direction, but the distance is the same. So that is the part that I wanted you to see. And now let's see what ChatGPT says. This one is false because, and it gives you an explanation. While 26, the absolute value 26 and negative 26 have the same absolute value, distance from 0, they are not the same point. Very true. The distance between negative 18 and 0 on the number line is negative 18 units. True. The distance between negative 18 and 0 is indeed the absolute value of negative 18. It's showing you that is the absolute value. So this is the part you have to get kids writing and using the language of the discipline, and using the right context and writing it so it's visually correct. And then the distance from negative 8 to 0 is the same as the distance from 8 to 0 on the number line. It's true. We're talking about distance. We are not talking about direction. So remember, when students are looking at sample items, or when you're using the sample items, especially absolute value, it seems like there may be only one question. That's okay. You can use the product that your district provided you for teaching the mathematics. You also can discuss how they're using and creating mathematical problems. Maybe they're making up their own number lines and then giving you the value, making sure that they are using the vertical lines, or maybe I think they may have been called pipes before as well. And letting kids be creative and try to see if they can find other things other than temperature, the absolute value of the distance between above and below sea level. See if they can come up with other ones. I do hope this was helpful. If you can take some time, get into ChatGPT, play around with it, be specific. Pick something that you want support with if you're an educator that allow you to be better in the classroom. I'm not recommending that you put this in front of students yet. Make sure that your district has a policy on what that looks like. Take a moment and play with the sample items. Take a moment and get really familiar with the mathematical practices. I recommend the book Routines for Reasoning. I do have an affiliate link for Amazon in the description if you want to read it. However, you can also go to this video and watch how I explain the mathematical practices. Thank you again so much for watching. I will see you on December 7th. Be sure to register so that we can get in contact and have some fun using ChatGPT.